Alright, let's look at instancing now, which is a very exciting technique and super powerful. I've been mentioning it in the series before, and let's actually now look at how to do that, or what it actually is. So before I start explaining, I'm just gonna set up a simple rendering network using a sphere as a base, or actually let's start with a box. So I'm going to put a box down here. From this box I'm going to connect the geo, or a geo, and we also want a camera and some lights. So I'm going to put a light there, and I'm also going to put a render top here, add a transform and a null. On the null I'm going to turn the display on by clicking on this blue circle, and on the transform I'm going to change this to a black background. Okay, so that's pretty much it for the rendering network, and now I can explain what instancing actually is. So let's say we want to make a grid of these boxes. So it just looks like a rectangle. It's actually like a 3D box. Let's say we want to make a grid with 20 by 20 boxes. So I'm going to show you how to not do it first, and then I'm going to explain you how to do that with instancing. So we could technically just use a copy here. With the copy, just change this to 20 and change the translate to like 1 or like 2. Just put another copy here and change this to 2, and there we go. There we have a grid. The problem with this is we have two different operators working on this, and they're both working on the CPU, and it's kind of annoying once you have to do a bit more complex operations, pretty much. So this is not the way to do this. Like, this could be a way for an example I'm going to show you, but I'm going to show you how to do this with instancing instead, because instancing actually works on a GPU, so it's very fast. When we click on our geo, and this is where like most of the magic is actually happening, we can look up here and we see instance and instance 2. Well, actually also instance 3, but we're not going to look at that now. So we have instance here, and we have to turn on instancing, and first nothing happens. So now we have a lot of different parameters to choose from here, and we can't actually do anything yet. So if I look here, there's no parameters to choose from. If I type something in here, nothing happens because we haven't set it up completely. What we want to do is we want to be able to use we want to define a source. I want to use a source from which we can get all these parameters. So like a position data, for example, like XYZ, or like scale data in these dimensions as well, or like a color data, for example. So we can use different kind of operator families for this, and we're going to look at how to do this with SOPs, with chops, and with tops. So that the thing is that you can use tops. It's actually very new. I think it's actually just in this 2020 version. So before you could only work with SOPs and chops, and I think also with DATs, but I'm not going to look at DATs right now. Okay, so what's actually happening is here that we're creating a kind of space geometry, and this can be any kind of SOP. This could even be an imported model, but in this case I'm just using a box, and we're just creating instances of this one box. So we're just kind of copying it, but we're talking to each instance on its own in a way, or we're more like defining a position, or like a scale, or the rotation value to each of these copies, basically. So let's look at how to do that with SOPs first. Let's I wanted to create a grid. So I'm going to use a grid SOP actually. And if I just drop this down here, make this viewer active and click W or press W on my keyboard, then we can see we have this grid here. I can right click and look at the display options and turn the points on. And then I can see at each of these intersections we have a blue dot. And for all of these blue dots, I want to, like these blue dots, I want them to be my position source basically. So I'm gonna add a null here and go to my geo, and now I can just, or let's actually be clean here and call this instances SOP, and I'm going to put that in the default instance operator, and nothing happens first, and that's totally alright because we haven't actually applied these values to anything. So if we now look at our drop-down menus for each of these, we have a few options here. So like free position data called P, 0, 1, and 2, and the same with N, which are the normal values. We want to work with the position values now on the translation. So we just need X and Y because we only have a 2-dimensional grid here. So we can just use P0 on the X and P1 on the Y. And now it just looks like we created a very big rectangle there. But if we insert a transform SOP here and turn the scale down to like 0.03, then we can see now we have a grid of our rectangles, boxes. So oops. Let's actually turn the viewers off for these. Yeah, so the thing is, with the copy example that I showed you before, it was kind of annoying to change the amounts of boxes that we saw. And now here I can just change the rows and columns of my grid, and so I change the position data of all these boxes. So this is a super clean and easy way to do this. And I can also insert more stuff into my chain here. So I can also add a noise. And the noise is actually only working on the Z value. So we actually only also need to select P2 on our Z translation. So as you can see now, and I'm going to zoom in a bit with the camera. So by changing the Z value to 3, we can now see our grid is kind of morphing, and yeah, I can change still like the rows and columns easily of this. Yeah, so again, what's happening here? We're using this one box, and I'm just going to show you. So you see a different example. I can just use a sphere and put that in the transform now. And now we just have a sphere as a base. So we put that in the geo. We have instancing turned on. We use this null as an as the instance OP. We can also use an operator for each of these different sections. So if we just put it here, we're just using one operator for all of these parameters. And then we're using the different position data. So X, Y, and Z positions of all our points here to define the positions of our boxes or whatever we have as an input here. That's actually a sphere right now. So, and here with the transform, we can actually change the, we just change the scale of this one input, and then it's changing for all of these. We could also, for example, change the scale with the an instancing. So we could use like the, no, that actually doesn't work. We can actually use like the position data to change the scale as well. But I'm going to show you a better example in a second. Okay, so I'm going to show you a few more examples with SOPs. So another thing could be that you just use a sphere, and I'm going to bypass this, and use a sphere here instead, and let's put a transform here and make this a bit smaller. So now I'm using pretty much doing the same thing. I'm just using the position data of my SOP here, and then before it was a grid and now it's just a sphere. And again, if I just turn the points on here, at each of these blue points there is now a sphere, or whatever we put in here. Now it's a rectangle box. Jeez. It could also be a rectangle. So I can also now put turn the noise on again, and yeah, so that's a nice way to work with this. Another thing could be that you use a tube. That's not a tube. And yeah, use this as a base for. Let's put that in here. That's a bit smaller. Yeah, so you can also use this as a base. So any kind of SOP you can use here, and you can transform it any way you want, and then you can use this as an instance source, or like instance as an instance operator for any kind of input that you have here. So as I said, this can also be different operator families. These actually can't. Like we're always instancing SOPs. So whatever we put in here, as far as I know, I don't want to say anything wrong here, but I think you can only instance SOPs. So but we can use chops and tops. I'm going to show you that now as instances. So let's put these two aside, and all right, let's look at chops now. Okay, so let's say I'm not gonna actually show you how to do a grid with chops, because that's a pretty annoying thing to do. I'm gonna show you first how to just align our spheres here in a row, just like in a straight row, which could obviously also be achieved with SOPs. But then I'm also going to show you how to make like a wave, and how to visualize our audio spectrum that I showed in the last video. So let's actually create a pattern chop here, and let's make this a ramp. And I'm going to go to the channel tab and call this TX, and I'm going to change the length to 50. So this is pretty much how many samples we have, and I'm gonna copy and paste this. Copy this length parameter. So right click, copy parameter, and paste the reference on our second pattern. Go to the channel there and call this TY. So we have like, we're kind of just creating a TX and a TY value ourselves. Here we're just kind of dropping in geometries, and here we're kind of just creating our channels on our own. So I'm gonna put a merge after this, and connect these together, and then I'm gonna add a null here, and I'm gonna call this instances chop. Instances chop. There we go. No, can't write. Okay, and I'm gonna use this instead. Now we're gonna get an error because we actually called them TX and TY instead of P0, P1 to P2. I'm just gonna get rid of these and get back to that in a second. So actually, let's just select TX. What you see now is it's starting at 0 and just going to 1. So we have 50 samples, so that means we have 50 spheres. So this is kind of the thing that I talked about with chops in the beginning, where we talked about where I introduced chops to you, is that we now have a number of samples, and these can be represented as geometry. So 50 samples here now means we have 50 spheres. Okay, so this is starting at 0. I want this to be in the center, so what I can do is insert a math chop here, and with P I can toggle this on and off. And I can change the range from 0 to 1 to -1 and 1. And now it's nicely centered. And yeah, so we've achieved our first goal by just putting them into one line. Let's say I want to make them, want to put them into a wave. So I can go to my geo, select the TY, and my TY right now is still a ramp, so I'm going to change this to a sine. And I could also drop a math, but I'm lazy, so I'm just going to change the amplitude to like 0.5. And now we have our wave here, because yeah, we just have an increasing number here with the ramp for TX, so we're just going from one side to the other. And with the pattern, it's like more or less literally being represented, so it's like exactly the same form, because this is also like the Y, like the graph is also like kind of going from like left to right is also the X, and the bottom to top is also like the Y. So that's kind of why it's exactly being represented. I could also type in ABS time dot seconds times like 0.5 here, and now you can see it's like just phasing this, so it's also phasing that. I could also change the numbers of samples here on my first one, because I just used this value. Yeah, so cool. That is working nicely. I could do the same with a Z value or Z value. I'm not neither British nor American, so I'm always like confusing Z and Z. So you can just create your own kind of parameters here, or like values, and then just merge them all together, and then just use this one null here at the end as an OP, or like a default instance OP, and then you can select the ones there. Like that is one way. Or if you want to, let's say, I'm just going to do this, copy paste this, and put that in there. I can now just use this specific one here for the scale, for example. And I'm going to put this back to 1. And now I can just use our TY as a scale. So now we just see them up there, and then they get smaller, and then they actually go to minus. So we could also change this to like a... no, we can't actually. We could change the offset a bit. So yeah. So you can either make like one instance operator at the end, and where you just merge everything together, or you can use different nulls for different sections here. So there's like pivot, scale, rotate, colors, stuff like that. Okay, so I'm gonna actually get rid of this, and also then we need to get rid of this. And I'm gonna show you how to substitute this for audio. So I'm going to put an audio file in, as we just did in the last video, and I'm just going to leave in the file that's there. It's not very important what that is right now. I'm going to add a math. Like, the thing is, we just want one channel here. We could also just go mono, but then it's just using one channel. And by using a math and then combining the channels with average, we're still using the data of both, but like from left and the right channel. But yeah, we just still have like one channel at the end. Okay, then I'm gonna use an audio spectrum on this, and yeah, just pretty much leave this as is. And the thing is, if I middle mouse click, we have a lot of samples in here, and we just have 50 in here. So we want to have the same amount of samples here and as here, because otherwise it's going to display an error, because it can't calculate like the instancing basically when we don't have the same amount of samples for everything, which pretty much makes sense, I think. Anyways, okay, so let's use this as a Y channel. So I'm gonna add a rename here and call this ty, so it's the same name as here. And then we can actually just substitute it and put that in there. No, we actually haven't resampled it. Okay, so what we need to do is add a resample here, because of the thing that I just talked about, that we have more samples here than there. We need to turn time slice off here and change the method to new rate, new interval. And now we can use this as an input, like as the second input here. And now we just have 50 samples here. And now we can substitute it in there. And now, as you can see, instead of having this sine wave here, we have our audio spectrum. So we could maybe, for this example, even turn this a bit higher, and we can change the number of spheres here. So we just have our audio spectrum now being represented as in 3D geometry, which is pretty cool. Yeah, so what we can do now, we could change this to be boxes, or no, to be even more efficient, we could just make this rectangles actually. And let's actually use this as scale data as well. So I'm gonna add a math here, and let's actually copy this rename, put that in there, and this in here. And let's rename this to size. I like size Y. And now we can change the range here from like 0.5 to 2. And just make another null. And put that into the scale. And for the scale Y, now select this. Actually, let's make this a lot bigger. It's like 20. Whoops. 20. So now the higher the y value here, or like the higher the value here is, the bigger the scale is gonna be. So with the camera, we could actually, for this example, just go down a bit. Whoops. I mean up. Fuck. Like this. And we could even go crazier with this. So something like that. We could also change the center to 0.5. No, is that? Yeah, to minus 0.5. So now it's just shifted and looks better. Which is kind of, yeah, we're just changing the center, so it's like if I didn't do that, you can see the Y is going. Actually, what we could also just do is not use this as Y value, and now we have it represented like this. And now if I change this again, now 0.5, fuck, there we go. Now it's actually shifted, so it's always starting at 0, this size, and then going up. So instead of scaling it in both ways, we're just scaling it in one way, pretty much. All right. So these are different approaches to how you can do this. All right. So that was about the chop part. There's many ways actually to do this, but many more possibilities how you can create stuff with chops. Let's now move to tops though, and this is actually like the most pretty example, I'd say. So first I'm going to show you how to make a grid, and just using tops as an instance LP, and then I'm going to show you how to create some cool noisy 3D shape to round this off nicely. So let's use actually it looks kind of funky. Okay, so I'm using the sphere again, and I'm gonna now create a ramp top and change the resolution to 50 by 50. And the thing is, here the samples are like responsible for the amount of instances we get. Here it's the points, and here it's the pixels. So it's a bit confusing, maybe, probably. Also what you need to do is you need to change the pixel format to 32-bit float, because otherwise we can't go into minus and it's gonna give us problems. Alright, so now let's use an add here and copy and paste this and change this to a vertical. And let's change this one to a red color and this one to a green color. I'm still not sure if this is the best way to do this. It works. So what's important is that you have this kind of gradient. And yeah, so let's add null here. And let's call this instances top. And now let's just delete all of these and use this instead. And let's also change our camera back to 0. So we just have this one sphere in our center. Whoops, why did that not work? There we go. So now instead of TX or like P something, I have RGBA as options here. So I can go to my translate and use R and G to do this instead. These actually all need to be 32-bit float. Why does this not work? All right. What we also need to do, we can actually work with math, with a math inside of tops. So we can just drop a math here and now change the range to -1 and 1. So it's kind of the same thing as doing in chops, but it's actually working on a GPU with pixels, and you get this weird kind of map here, and this is going to produce a grid at the end. So let's actually zoom out a bit. And yeah, that's a way how you can create a grid. So pretty much what we're doing is, instead of using like a ramp here, we're just using a ramp in pixels. So we're just going still from 0 to 1, because it's just like, yeah, like this is our R channel pretty much. So it's going from 0 to 1, which I just said. Fuck. So colors are also just going from 0 to 1 always. So the thing is, this kind of still works. I can't actually explain why this works. Like, it's just being shown as black, the -1, because this part is actually going to -1 down here. But it's still, it can still be used as instancing numbers or like positions, anything like that. Okay, I hope that makes sense. And now I'm going to show you like a cooler example, or like a more exciting one. We can just use a noise to create some cool 3D graphics. And I'm just going to put that into here instead. And we also need to change. This is very slow right now because it's a lot of stuff going on there. I just want 50 by 50 again. And I also want this to be 32-bit float, and we also need to turn off monochrome. So now you can see this kind of point cloud there. And this is probably a lot more convenient if we just take boxes, and a lot faster. Or let's actually take a sphere, but let's just go down with this to like 10 by 10. It's totally enough. Even like 5 by 5 maybe. All right. Anyways. This is fine. If we actually look at our camera, this is a not 3D cloud, in fact. Right, we also need to take B in there. Now it's a 3D cloud. There we go. Okay. Fuck. Wait, let me just fix this. You don't need to understand this, what I'm doing right now. Okay, there we go. We can now go and change the period to like 10 and go to the transform page and to the TZ and type in apps time dot seconds times 0.5. I just typed something wrong. Seconds more like 0.1. And now you can see this morphing kind of point cloud there. And we can easily change the amount of spheres shown by changing the resolution here. And you can still see it's still running pretty smoothly there at 60 FPS. And we can easily change like how this is supposed to look. So this is a pretty neat way to create like these kind of point clouds. And yeah, this is like I haven't actually worked with this a lot. This is also pretty new. Like the fact, as I said, that you can even use tops as an input, and like as a instancing input. Before it was also possible by just changing this to chops, so you could just convert that. You can obviously still do that, but it's not really necessary anymore. Yeah, but it's pretty amazing what can be done now. You can create like crazy point clouds with this. I'm gonna link like a point file in tutorial, which is also pretty new now. If you look at that's like this point file in and point file select, these two operators are pretty new, and they allow you to use like OBJ files and stuff working on the GPU. So it's exciting stuff happening here. And I still have to dive deeper into this, but it's like a very basic example how you can create something like that. Yeah, so for the instancing, as I said, what you can also do, let's just quickly do that here. If you go to the second tab, you can just select the colors that we have now. Let's just select 2 colors, and now we have like a different color for every sphere, pretty much. And yeah, kind of as a task, because we looked at like audio analysis a bit, and now at instancing, I would ask you to kind of try to make something audio reactive with this technique view. And as a little tip, you can use any of these parameters to map something from the audio to, and that's kind of where it gets exciting, you know. And yeah, so I hope this was understandable. There's a lot of room here where you can play. There's also other great tutorials on instancing, and then in the next video, or like soon, sometime in the next videos, I'm going to talk about how you can actually start a project, and this is a great way how you can start a project. Alright, then I'll see you in the next one.